In this video, we're going to be analyzing a projectile and we're going to be finding the overall velocity of the object at any point during its flight. So first of all, we have a golf ball being struck and it's being struck 40 degrees above the horizontal and leaves the club with a velocity of 50 meters per second. So the first thing we're going to do is we're going to go ahead and create an X and Y column as we normally would. And the reason for that is because everything moving horizontally has no forces, therefore it is moving at a constant velocity. And then everything moving vertically does experience a force of gravity, which is going to cause it to accelerate. So we want to make sure we split everything into two columns. Now, if we go ahead and find a Vx, which is the x component, and the Vy, which is the y component, we can go ahead and use some trig functions. So for the Vx, because it is the adjacent side of this 40-degree angle, we want to use the adjacent side in combination with the hypotenuse. So Vx is going to be 50 times the cosine of 40 degrees, and that's going to equal 38.30 meters per second. And then we're going to do something similar for the side opposite of the 40-degree angle. And then Vy, we're going to end up using the sine because sine utilizes the opposite side of our triangle along with the hypotenuse. And that gives us a velocity of 32.14 meters per second. Okay, so what we can do is go ahead and place those two into our columns. So we have a horizontal velocity of 38.30, and then in the y direction, we have an initial velocity of 32.14 meters per second. We have our acceleration due to gravity as usual, negative 9.8 meters per second squared. And then what we're going to do is first we're going to go ahead and solve for the total time. So we're just going to use that total time as sort of like a reference of where we're at in our flight. So the way we can do that is when it comes back to ground level, the final velocity and initial velocity are going to be the same number, but different signs. So once it comes back to the ground, the final velocity is going to be negative 32.14 meters per second. All right, so let's go ahead and solve for that total time first before we get solving for some overall velocities. All right, so we got a total time of 6.56 seconds. So I'm going to go ahead and put that here. So that is our total time in the air. And if we go ahead and divide that by 2, we can figure out how long it's going to take to get to the peak, the halfway point, which is about 3.325 seconds. Okay, now like I said, I just solved for that just for reference, and you'll see what I mean by that shortly. So our goal in this video is to find the overall velocity at any point in our flight. So say, for example, we wanted to find the overall velocity at t equals 2 seconds. What we would do is we'd be looking for the vertical velocity at that point because we know the horizontal velocity is going to maintain constant at 38.30 meters per second. So we basically want to piece together a triangle and find a resultant. So for example, we have a horizontal component of 38.30, and we basically want to just find this vertical component over here to see what's going on. Now, if I'm finding it at 2 seconds, I know it's still on the rise because at the peak is 3.325 seconds. So all I have to really do is plug in the 2 seconds along with these other blue numbers over here in order to find the new velocity. So I'm looking for a VF because I'm not going to use this VF because that's when it goes all the way back down to the bottom. So I can say negative 9.8 equals VF minus our initial of 32.14, and then plug in the 2 seconds over here. And then what we can do from there is cross multiply the 2 over. And then add 32.14 to each side. And then we would get a final velocity of 12.54 meters per second. Okay, and that's the final at 2 seconds. Okay, so that means that this part of the triangle is going to be 12.54. Now, that means at 2 seconds, we have a combination of this horizontal component, which means the same, and we have our new vertical component of 12.54. So if we just use Pythagorean theorem, then we can go ahead and find the overall velocity right over here. All right, so using the Pythagorean theorem, we did a squared plus b squared equals c squared, which is basically just adding up the square of each portion of our triangle and then square rooting it, and we have a overall velocity of 40.30 meters per second. And what we can do in addition to that is we can also find the angle theta. So if we know that it's rising from being from 40 degrees going 50 meters per second, as it's rising towards its peak, two things are going to happen. Number one, the overall velocity is going to slow down. And then number two, the angle is going to decrease until it has basically no angle at the very peak. So we should expect the 50 to drop, which it did drop to 40.30, and we should also expect the angle theta to decrease as well. So what we can do is we can take the inverse tangent, and tangent is opposite and adjacent. So the opposite end of our triangle is 12.54, and then the adjacent part is 38.30. And then we get an angle theta of 18.13 degrees. Okay, so which did hold up with our idea of our angle getting smaller as it's rising towards the top. So basically, if you want to find the overall velocity at any point during its flight, you're going to have to find a new vertical velocity to combine with your horizontal velocity. And then from there, you would use the Pythagorean theorem to find the overall resultant velocity, as we did in this green box over here. And if you want to find an angle in addition to that, you can go ahead and use something like the inverse of tangent and then plug in your two components to find that angle. If we're looking at velocities in the second half of the trip, we should expect to get a negative velocity because the negative is directed downwards. But that's all still going to work pretty similarly. You would just have a triangle that looks like this. It would be 38.30 degrees horizontally, and then you would have some kind of velocity going downwards, and then you would just close off your triangle this way, and your angle theta would be directed in that direction. But either way, you would solve for the resultant velocity with a similar method. You would just plug in a different time into this setup over here, which would give you a different VF, and then that would give you a different number right over here for your Y component. So I hope that was helpful in helping you take a look at a projectile problem to find the overall velocity at any given time. Thank you for watching and listening.